Well, welcome. My name is Søren Salomo, and I'm the head of the Department of DTU Management Engineering, and that is also the place where Kirsten has become professor, and I'm very glad to see so many people attending here today. It's a pleasure to see you all, and that we'll all experience Kirsten's presentations today as the inaugural lecture for the Professorship in Climate Change Economics. There's a little formal part here, which I'll do very fast. That is a brief review of Kirsten's CV. Basically, I would just like to mention two things: that she has a Master in Economics from Copenhagen University in 1983 and also earned a PhD in Economics in 1997 from RUC. But most importantly, now she's at DTU, and that's certainly the right place to be to look at climate change economics. And not the least, because Kirsten has proven over the past years, as she's been for DTU or Risø DTU, as being one of the prominent persons in the Danish context, but working into international environment also in promoting climate change, mitigation and adaptation issues from an economic perspective. So she is, in fact, I believe at least, one of the prominent persons in Denmark, and I'm pretty sure that with this lift of professorship she experienced, she'll be more prominent. So that's what we're looking forward to today and in the future. Kirsten will give her presentation today. It's about 45 minutes, and there are no questions afterwards, at least none in the auditorium. But if you have questions, Kirsten will be here, and we'll have a reception outside, so there's plenty of room to discuss and ask questions if any should come up during the presentation. Kirsten, I'm very much looking forward to your presentation, and once you're finished, I'll come up here again. Okay. Thanks a lot.
Thank you. I'll try to present some sort of discussions which I think are quite important, because we are seeing a lot of climate change events every day in the media, very catastrophic pictures. And we also are coming to the next IPCC report where new scientific results will be presented. And I think it's important that we, in a solid technical way, are trying to address how should we interpret all the results that we are seeing in the media all the time. Is it time to make very drastic actions? Should we promote very big climate change adaptation investments or climate change mitigation? Or what should we really do to understand all this information that is coming all the time? So that's what I'm trying to go into. But before we go into that, I would like to present some acknowledgements, because a lot of you are here today. All my partners and friends and all the people I work together with in my scientific career, since I started in Copenhagen University and took my PhD in Roskilde University, and in the sort of climate center research partnership we have in Denmark with the DMI, GEUS, and Copenhagen University and Aarhus and so forth. All of this is actually the background for my position as a professor. So I'm very glad to see a lot of you here, and you are really the background of what I can present today. And I also like to thank my sort of nearest colleague in our program at DTU Management Engineering, and some of my best partners who have helped me also to make the presentation, where Martin, for example, has been quite busy. But I also brought some pictures of Bert Bolin. As you know, he was a guy who established the IPCC back in 1988, I think it was, and he's actually also the background of this very integrated economic science engineering approach that we are actually able to work on in climate change. And also my dear friend and sort colleague, Professor Shukla from the Indian Institute of Management. Those of you who know him, you know he's really a sort of inspiration. Climate change is maybe happening. At least we see a lot of extreme events. So some years ago, we saw this flooding of the highway to Stockholm, and this was pretty dramatic and prevented cars from going where they wanted to go. We are also seeing infrastructure events in Mexico right now. The same with the bridge here, rather dramatic. And in Japan, they just had a big cyclone, which caused a lot of damages. In New York, I think it was last year, we had the flooding of the yellow taxis. in Colorado. We have houses turning around. And in Paris, years back, we had this hot spell where about, I think it was 18,000 people died. It looks nice when you look at the beach here and the relaxed people. But it was actually very serious. And a lot of elderly people died. We also had forest fires in Australia, but we had a nice adaptation option. This guy was able to comfort the little animal, so it looks good. But the most serious is maybe that the most vulnerable part of our world is in developing countries, because in these low-income countries, very big shares of the economy is in agriculture and in the primary sectors. And when the flooding is coming, it's really serious. You have the dirty water mixed up with the clean water and the flooding. And this is a serious ethical issue that at one hand, greenhouse gas emissions and the concentrations in the atmosphere are the cause of the global warming we are seeing. And the ones most hurt is the one in developing countries that are not really the cause of the problem. So when we are talking about climate change policy, there's a very big ethical aspects in what we are doing. In a traditional perspective, the way we'd consider the problem would very much be like we have some sort of climate change impacts, which could give some physical impacts, some economic impacts, and then we would like to optimize more or less what we are doing. So if you are thinking a sort of rational planning model, then you like to see how much it pays off to invest in adaptation options, and then try to design some climate change policy where you get rid of the worst consequences. But you will not go down to a level where there is no sort of impacts left. And if you are following this sort of easy framework, or easily understandable framework, then you will of course also look for some estimates of how big are these damages and how much would it pay off to invest in avoiding the damages. And that's what I will discuss a little bit and try to question a little bit whether our sort of perspective should be presented in a simple way like that, or if we should go into a more sort of risk assessment framework. What can economists offer? We have several economists here. I know them from my study. And at least we can offer some sort of cost-benefit analysis. Well, the logic is that we would try to assess the cost of these climate change damages, then assign monetary values to as much as possible, and then see how much this is worth spending in order to avoid these damages and to make a balance. And this is very much done on the basis of very aggregate measures for the whole world. What is it worth that the whole climate system in the world, maybe 100 years from now, would change in this way, and some people would die, some other would have more agricultural production, and so forth. And this could very much look like this sort of picture I have here of Lady Justice that is trying to weigh what is the most important. One people having a better life maybe in Denmark. He's a happy fat guy because we are the most lucky, happy people in the world maybe. And then you have some other poor people here, but they don't count the same because they have a lower income and so. And that's often what we see in cost-benefit assessments in climate change. So it's a bit absurd because we can end up in a sort of dilemma where we would have to consider what is the most important, that some people are flooded in Mexico, or is that more important than the pleasure of us in Denmark? We could maybe grow wine and make red wine here and enjoy life. I'm just putting it to the edge, but it's actually what is hidden in some of all these calculations. So I think we should change focus when we are working on global warming and impact assessments. And first of all, this is more urgent, maybe even more urgent than before, because I would think that it's very likely that the global temperature increases would be more than 2 degrees. I will show you some sort of figures on that also. So extreme events like storms, flooding, and hot spells could be more frequent, and serious values are at stake, like health, mortality, biodiversity, historical heritage, homes, infrastructure, food, and so forth. So it could be very important to avoid some of these impacts, and they should not just be hidden in some very aggregate general measures. I think that a risk-based approach could be more relevant at cost-benefit analysis, because we cannot really just put monetary value and put everything into these very aggregate equations. So when I'm talking about risks, I will define it in the traditional way, that the risk is the probability of some climate event times the consequence. And the climate event, it could be like temperature, a given temperature, precipitation events, storms, other sort of things. So in the diagram here, you see here we have this some climate event, and temperature change is just an example. And what we have on the y-axis is the probability of this climate event. And I have two different distributions here that I will use through my lecture in order to discuss some of the differences between what happens if you assume different distributions. And this is just a very traditional normal distribution, and this other one has more fat tails. And then I will mix it with something I will call a damage function, which is the black line you see here. And the damage function is representing, maybe in monetary terms, maybe in some other measures, the consequences of some climate event. So I'll try to discuss a little bit how these sort of probability density functions of climate events and damage functions together can generate very different results. Because it's interesting to know what this risk is, because the risk is the sort of argument for doing something, that we have a high risk or low risk, and if you have a high risk, then it's really worth doing something. And my approach here in the presentation is that I will display some regional and sectoral differences in what could be expected with climate change. And then I will focus on marginal damages in some critical areas, show you some sort of hotspots where there could be some high sort of risk of extreme events, and discuss a little bit what it means if we also take care of risk attitudes. And consider the uncertainties of climate data and the damage cost functions and see how this play together. If you go back to the discussion about 2 degrees. Last year in November, the co-chair of IPCC Working Group 1, Thomas Stocker, and he's the chair of this Working Group 1, which is publishing its report next week. He was writing a paper to Nature Climate Change, which I think is quite important, because it is trying to see, with a simple connection of climate models and the climate signal in the model, how much would be needed in order to keep the global temperature below this 2-degree level, and other sort of degree levels. As you can see, it's different sort of degrees. And the conclusion from this paper is that if we want to stay between the 2 degrees, and as you know, 2 degrees was the central EU sort of target, and it was very important in relation to the COP meeting in Copenhagen in 2009. Then if you want to stay between the 2 degrees, then you have to follow to be able to reduce with a growth rate or reduction rate every year, as you can see on the y-axis. So, for example, if we are only able to start our path to reduce to 2 degrees in 2020, then our annual reduction rate would have to be more than 2%. So it's really increasing very fast when we move out in time before we are able to do our efforts. So in that way, I would say that the window of opportunity is really closing. And I will try to illustrate that argument a little bit more by showing this figure that I borrowed from the European Environment Agency. And you only need to focus on actually on this number here. Because in the period from 1990 to 2011, the European Union was only able to reduce with 17.6%, which is less than 1% per year. So the EU, who are considering itself as a front runner in the global climate policy race, they were below 1% per year. And that was even in a period where you had the financial crisis and you had the integration of Eastern Europe, which made it much more easy for the EU to reduce emissions, because when you have economic recession, then your economy is just going down and you have used less energy. So just to put it into perspective, if we have to go for a reduction that is more than 2% a year, then it would really be a revolution compared with this EU achievement in the past period. So that's why I argue that maybe you think I'm too pessimistic, but I don't really believe in this 2-degree target. So in some of the new important research insight that is important when we discuss extreme event and climate risk is also that the probability of extreme events could be increasing with higher temperatures. And try to look at this figure where you can see that over time, what would happen, where these sort of curves you see here, they are again these probability density functions of different temperature targets. And over time, with increasing greenhouse gas concentration in the atmosphere, then these PDFs, probability density functions, will be displaced in this direction, but they could also be broader and have longer tails, fatter tails. So it means that it could be quite likely that some more extreme events could happen in the future. And I think that's one of the important insights I hope that will also be discussed in the new IPCC report. It's quite important whether it's really likely that some of these higher temperatures could emerge over time, which actually would be a trigger of much more extreme events. Some of the work that is done in some of the new research projects are actually also showing that some more extreme events could happen in the future. This map is showing the probability of having strong storms. And if you take a look out in the North Sea, it's very red. So it means that it's 80% likely that the storms in the future would be much stronger than the ones we see today. And we have different sort of maps that can show that. You have some stormy areas, and it's even... in particularly out in the North Sea, it could be quite important because you have all the oil rigs and the sort of, in these areas where you have the sort of offshore wind turbines, it's quite important if storms really are getting stronger, and it could create some damage. So it's some emerging research that goes more into detail on these different regional patterns of storms and hot spells and other things. Sometimes we also see game changer. This is a Fukushima plant. I brought this picture because Ben from the nuclear department is here, and he's always sad if we don't talk about nuclear power. I know nuclear power is not a climate change issue, but it's still important to notice that sometimes extreme events happen. And the tsunami in Japan and what happened with Fukushima is actually a very extreme event, and it had a low probability, but it actually happened. But it had triggered very dramatic decisions. For example, I think it was 2 days ago, I heard in the news that now they have closed all nuclear reactors in Japan due to this problem. You can call it overreaction, maybe, but it happens that people take this very seriously. So I think it's worth to think about. So it's important that we integrate risk attitudes in our assessments. Another example of something unexpected happening was in the Olympic game in 2008, where you had this Danish 49er boat, and the mast was just cracking down. Actually, they were able to win, but we're not always able to win when such unintended events are happening. In this summer, we also had these very serious flooding events in Germany and the Czech Republic. And it was actually going very far, and if you followed the news, you would know that it was actually getting very close to some of the old historical buildings in Prague and some very key natural and historical assets. And it brings me to some more detailed results about what could happen in Europe with future climate change. I have borrowed this table from a study made in an EU project called Pesetas. And they were doing some very detailed regional damage estimates for different parts of Europe. And as you can see what we have here, we have Southern Europe, Central Europe, South, North, Central, British Islands, Northern Europe. And they were looking at the agriculture, sort of river flooding, coastal flooding, and also some health impacts and tourism, which I've not brought here because it takes too much space. But the point here is that if we were only looking for aggregate results, we would only look at the EU column. And as you see, agriculture, it goes up some places, goes down some others, so it's not really giving a detailed picture. And if you go to the next one, the river flooding, as we saw this summer, you can see that the person's dams are actually located in very specific areas, Central North Europe and Central South Europe, where a lot of people are sort of threatened to these damages. And the same is the case with coastal flooding. So the point here is that there's a very big difference in different regions of the vulnerabilities to specific events. So it's not so interesting only to look at this aggregate damage cost. And this figure is from the same study, showing whether, in terms of sectors, and measured in relation to annual GDP loss of reduction of the growth rate of GDP, the gross domestic product. And you can also again see that there's a big difference because in the Southern Europe, the problem is the agriculture because you have less precipitation and increasing temperature. In Northern Europe, we could maybe have a bit increase in agriculture because it's warmer and wetter, as they always say in the DMI. And then if we take this Central North and the Central South, you have the problem with the flooding. And think about what could happen in an EU meeting when they're beginning to discuss whether losses from climate change should be compensated. They would have to go into all agricultural policies and discuss about subsidies and compensations and who should pay for all these local damages and so forth. If we take an economic perspective on the extreme events, I have been inspired by a paper that I saw of Martin Weitzman with fat-tailed uncertainty in the economics of catastrophic climate change. And what he does is to focus on the extremes of critical probability distributions. I will show that with some of the figures. And then he's discussing how cost-benefit analysis is used as a decision criteria and what happens if you take the other sort of more risk-based approach. And of course, this has something to do with a discussion also with Bill Nordhaus and the more traditional economists about how much is it worth and how big is the climate sort of risk. And this discussion about these fat-tailed distributions and the risk approach is very important, both in terms of, I think I said it already, adaptation policies and mitigation policies, because it's more or less a sort of bar you have for how far you should go in these policies. In the damage estimates, as I said previously, we are focusing on the risk defined as the probability times the consequence. So we go back to the figure I already showed you and try to see how these things interplay. And in the damage function, which is the black line we see here, it's a measure of what is the economic cost or some other measure of some climate events and climate change. Some of the points are that we have to consider whether negative climate change impacts in one sector can be offset by compensations in other sectors. And as I said, Mexico is flooded, but wine can be produced in Denmark, and should we just add all this and then say we are happy if the utility of us drinking wine made in Denmark is higher than the disutility of people living in Mexico flooded. But what happens if some values cannot be substituted? And that's the discussion that Weitzman is having with Nordhaus. Because in the Nordhaus utility function, which is behind this damage cost assessment, then you can substitute. if some people are dying here, you can make others more happy with increasing the output in some sectors or so. But I think we can well argue that everything cannot just be substituted. So if some people are dying, some islands are disappearing, or some biodiversity, I don't think it makes sense to say we can always just substitute. And that's the reason why I have tried to go a bit more into this health impacts, because I think health impacts, mortality, as a consequence of climate change, is an area where you cannot just substitute. So it's interesting to discuss what sort of risk would we really be willing to pay a lot to avoid. So it's about what is at stake. Is it just some sort of, I would even say just some smoke coming out of the pipes and some air pollution? Maybe it's transported to the UK or Sweden, or maybe it's not so serious. Is that the problem? Or is the problem that some patients could be dying in the university hospital, Rigshospitalet, because the power emergency is not working and all the sort of intensive care patients are dying in the flooding? Is it some small children that could die because you have dirty water coming out of the sewage system and mixing up with the soil on the playground, and some children are dying? Is it some historical values like old churches, 1,000 years old, and only the oldest one in Scandinavia? Or is it just some buildings or houses or things in the city? There's a difference, I think. And we can have different risk aversion to these. And I think it's worth arguing that if it is more like small children dying because the playground in the kindergarten is dirty and just one child dying, I think we would be very risk adverse. So it's something we would not really accept. And you can mention other examples, also losing some historical values and so. Then we will have other areas where we are more risk neutral, because if our basement in the house is flooded or we have some water on the road, then we can buy us out of it, we can repair it, and we can get back to the normal condition. I don't have any examples of areas where we are risk lovers in climate change, where we think it's exciting, like playing some bingo or lottery. But maybe some of you have. I don't have. But if we are risk averse, or if we are risk neutral, it has implications on our damage function. Because if we are risk adverse, then we are willing to pay more to avoid the risk. So it will make the damage function more steep. So we made a little example. Martin and I were trying to make a little back on the envelope example here, where we're trying to see what could happen if we have one of these hot spells as we had in Paris some years ago. And we assume that there's some daily sort of temperature increase in this hot spell with either 4 or 6 degrees above the mean annual temperature change in the summer months. And then, according to these World Bank and WHO reports, it could mean that the mortality would increase with 2% for every 1 degree increase above a certain sort of location-dependent threshold, which could be like 23 degrees in Denmark. And then we will see what would happen if we use a damage function like the Nordhaus function, where you can substitute between different things. One person is dying, but some other things could compensate. Or if we have a sort of more simple welfare function, which is the only linear sort of function we are using here. So we were making some calculations with different temperature increases in the hot spell, as you see here in the top, 2, 4, 6, 8, 10, 12 degrees, and then calculated in the Nordhaus function what would be the sort of loss. In the Nordhaus function is a welfare loss, so gross domestic product. In our simple calculation, it's just increases in number of people dying. And in the figure, as you see here, you can see the different functions. It's the same figure I've seen all the time. The only new thing now is that you now see these new sort of 3 different damage functions. And The red one is when we have 4 degrees. The blue dotted one is when we have the 6 degrees. And the black one is the Nordhaus sort of function. So it shows that there's a difference in these damage functions, and they could even also be displaced and moved in different directions. And then the next step is to make the risk, the mortality risk, where it's the probability times the damage. So there you see a new picture, because if the temperature increase in this hot spell was the mean value here, then you can see this sort of normal distribution is really giving a very high risk. But if we go out in this area here, then the fat tail distribution is actually resulting in a much higher risk. So it's only when we are in this area, which is very close around the mean here, that this sort of normal distribution is giving a higher risk than if our distribution was more fat-tailed. So in this way, it shows also that there's really a difference between if you are just having this normal distribution and you only, like in many cost-benefit analyses, you only will focus on this sort of mean expected value, or if you're taking the perspective of this whole sort of range of the distribution. And then I thought, because it was a discussion I had a lot with Jens Christian and some of our other colleagues in the Regional Climate Change Research Center we have, what are we really doing when we are trying to make these uncertainty sort of discussions with climate change impacts? Are we just putting probability density functions also on the economic of the cost, on the damage, on everything, and then we're just putting everything together? So I thought that we should go a little bit more into a discussion about what is a sort of structural damage uncertainty. I'll try to explain what I mean. That in some cases, for example, if you have a climate model or some sort of physical science model, then you can have some sort of probability assigned to different values. But if you go into economics, and maybe it's only my colleague economists who will understand me now, then it's not a matter of probability, rather, or uncertainty, why you think you can substitute one value with another, or or how the shape of the function is. It's more an issue of how you see different welfare perspectives and preferences and risk aversion of people. It's not something we, in a meaningful way, I think, could just say this is just uncertainty, and we just put uncertainty on it. So I thought that we should try to look at, and then I would call it structural uncertainty. And structural uncertainty, in my terminology, is more about what do you include in your model, what do you assume. So I was just trying to make this combination where you have two different damage functions. One is sort of concave and the other is convex, and then you see what happens. And what you can see, and you again calculate this probability times the damage. And here you can see that there's really a big difference in terms of risk if you are in the normal distribution. But if you just go a little bit away from the mean value, then you're getting a very big difference, and the other sort of functions are coming into play, and it makes a difference whether you are using this damage curve or the other one. So my argument here is just that we have to estimate a broader range of these probability density functions. We need to have more climate modeling in order to know where we really are, and we also need to be more careful and dig a little bit deeper when we make these damage functions. So now we turn to something more concrete, and this is the end of my lecture here, because in 2011 we saw a serious flooding in Copenhagen, and this is one of the sort of railway stations. I think it's one of these up in the North Sjælland with this Whiskey Belt train line, and we had this serious flooding. And we were trying to work on similar issues in Aarhus, in our climate group. And together with Carsten and Henrik Madsen from the GSI and so, we made this flooding map for Aarhus. And this requires a lot of details about the sewage system and how the water is running and all that. And we were able to make this sort of flooding map where you could see which sort of assets and activities in the city that could be flooded. If you have different, if it was like a 5-year flooding event or 20-year return period, 100 years and so. So we were able to tell with all this geographical information system data, whether it was a housing area, if it was a road, if it was some church or whatever, or a kindergarten and everything like that. So here you can then discuss how can this be used as part of a risk assessment and adaptation decisions. And we were making a cost-benefit analysis for Aarhus to see what was coming out. And as you can see, a lot of damages on the buildings. You have some road damages. And you also actually had a very big factor in terms of time loss, because with the flooding events, all the main traffic roads coming into the center of Aarhus could be flooded, and people could not go to work, so they will lose a lot of time, and a lot of activities in the city could stop. But then my question would be, is that a very important result? Of course it is, because we did it, so it is important. But I would say maybe the things that we couldn't say very much about is what we have not, which could maybe be more important. And then I would return to this picture again, because what about these old churches you have in Aarhus that is these 1,000 years old, and the crypt and these paintings on the walls? What about the children? One of the vulnerable area was the kindergarten, where you could have one child getting sick or dying. And that was not reflected in the cost-benefit analysis, because what would we really do about that? Because you would have to make very big preventive measures to avoid that. So my conclusion then would be that it's maybe not so relevant just to do this cost-benefit analysis. At least it's worth doing it, but you need more information in order to see how decisions should be made. And this is just to show you how we actually do these assessments. And we were making something we call the Danish Integrated Assessment System, called DIAS. All systems need a name because it's sort of a child and it lives its own life. And with all our partnerships with climate modelers, the GEOS people and the DTU Environment and the DSI and Aarhus University, we were able to get a lot of data together, because first we start out in this left column where we have the climate models, and they can deliver data on the temperature, the precipitation, the wind speed, the air pressure, the whatever. And then, and this is done for Denmark, land cover data we got from Aarhus University, where we have all land use categories, the nature area, we have the buildings, stocks, the infrastructure, administrative units, and we have the digital elevation model, so we know how the water could move. But you also need socioeconomic data, because it's important to know where people are living, what are the economic sort of activities, high income, low income, education, things like that, in order to know how people could react to different damages, and the traffic and the behavior and so forth. And then we were able to use this model to calculate some of these, make thematic impact maps and calculate some of the risks. It's just showing how difficult it is to be an expert in climate change impact assessment. You have to have a lot of good friends. But actually Denmark is a good example here, because we have a lot of these data available. So this is more a matter of how you get access to all this and to avoid a lot of expenditures from buying data and so forth. But I think there are really very good opportunities here. So my conclusions are that damage estimates and policy recommendations, they strongly depend on major structural uncertainties, both related to climate signal in the climate models, the physical impacts coming out of different climate signals, and the damage cost functions. And key climate modeling information include appropriate, always a good terminology, temporal spatial resolution and shape of the probability density functions. And it's interesting to look at these hotspots with valuable assets. And damage estimates, they vary between market commodities like agriculture and some very unique values assets that we don't want to lose. If we turn our view to DTU, I think DTU really has something to do here. Because all these standards that we're using when we are making buildings or bridges or houses, whatever, they should reflect this more sophisticated perspective of uncertainty and risk. It's not enough to say that we protect against some 30 years event or whatever you think about. It needs to be much more nuanced. And I think we can really do a job here and be much more detailed about, maybe it's not the same standard that should apply in every place you make some sort of house or building or traffic system. Maybe it should be different depending on these things. And I think that this risk aversion approach should be reflected in climate policy and risk-based adaptation of investment decisions. And then finally, some famous Danish environmental debatteur, he's always saying we should also remember the positive things of aspects of climate change. So I would like to finish with this picture where you see that the dog and the child, they're actually having a lot of fun out of this climate change in sort of Colorado. So it has a positive aspects. Thank you.
Thank you, Kirsten, very much. Maybe I shouldn't wrap this up because Kirsten kind of nicely wrapped it up with this Danish integrated, what do you call this, assessment system, which I think makes it very well. We are at DTU Management Engineering. We are interested in decision support tools. And there is a very good reason that Kirsten has become professor here at DTU, because DTU is the place where we put forward engineering, have new thoughts about that, new solutions, certainly deliver something towards mitigation and adaptation activities, but we need some kind of direction into that. And that's where Kirsten comes in, because coming from the climate models, then providing some economic perspective on where the biggest benefit is of investing into adaptation and mitigation activities, that requires us and you. So I'm very happy that you're at the department as a professor now, and I'm really looking forward to both brilliant but also with a sufficient amount of modesty, as you showed today, that we're really putting something forward here. Thank you very much. And last time I had to go outside and look for it. Now we put it down here. Here we go. Thanks a lot. And we would very much love to see you at the reception just outside the door, and stay and enjoy the food and drinks and talk to Kirsten and all your colleagues. Thanks a lot.